Hi, good morning, ladies and gentlemen. This is Zhong Chen from Peking University. I'm very glad to join the Ethereum in the Enterprise 2020 Asia Pacific. So, I would like to introduce some security analysis technology for Ethereum smart contract. So first, I would like to introduce our teams in my information security lab at Peking University. So we are the leader of the open source project. It's called the GMSSL. That is some local encryption algorithm with the open source implementation maintained by our team. So we are also a social member of Ledger in Linux Foundation um, since 2018. And right now we have the PhD student and master degree student to work in the security analysis of the smart contract and some other related topics research. So the team also the first prize winner of Tokyo Long Hash blockchain hackathons in the April of 2018. So here, I would like to introduce some research background and research status, and some ideas, content, and some achievement, then give a summary. So we may note that the smart contract is an application running on the blockchain architecture platform. So the Ethereum give a very good example, and also, the smart contract, they have a technical feature like open and transparent, guaranteed execution, and non-tamperable, not depend on the trust third party. And also, we can see that the application is quite broad. It covered the digital currency, financial asset, transaction settlement, digital government, enter anti-counterfeiting, and data services. So there is also a high security requirement. This smart contract defect can cause a major property and data losses. So there is a much more examples shows uh, that happened before. So ensuring the security of smart contract is critical to the credibility of blockchain applications. So we can see some research background. The challenge issue come from the spatial runtime environment, like the gas resource mechanism, exception handling mechanism, and the persistent state, etc. So various source of security threat including security breaches and abnormal transactions, etc. And the state space expand rapidly, so certain vulnerability need to capture to specific transaction sequence, etc. And some general idea is that the vulnerability discovery and abnormal analysis technology for smart contract and the security analysis tools for tool set for smart contract. So it is also intended to improve existing vulnerability discovery technology and clarify abnormally classification and to find anomaly features, identify the cause of abnormality, and also the tool sets to fit the gaps in the security analysis tools. So current research status, there is a lot of work, typical work to cover the security vulnerability classification and security vulnerability detection and security vulnerability exploitation and security attribute verification. Um, so here list a set of publications that covered the mentioned topic here. So the security vulnerability detection research focusing on known pattern vulnerabilities. Security attributes verification research rely on manual definition of rules. For the anomaly analysis, so there are also some publications to cover the gas resource mechanism optimization and gas resource consumption optimization and gas resource consumption estimation and anomaly related vulnerability detection. So here's also another list of paper publication which shows more pay attention to the gas exhaustion anomaly and the lack of research on other anomaly types. So most focus on the gas resource estimation and optimization, but lack of analysis of abnormal causes, right? So here's a summary to ensure the security of smart contract. The current research work has some limitations. That is, shows vulnerability discovery, focus on the known pattern vulnerability, and rely on the manual definition of the rules. Anomaly analysis is lack of overall understanding of anomaly and lack of analysis of the course. So some research ideas come from our research team, like the student related to this year, and they show some scientific issues cover the multi-scene integration, practical smart contract vulnerability discovery system framework. And the other way is a semantic driven systematic smart contract transaction normal diagnosis method. So the research key point is that one is a multi-scene integration, practical smart contract vulnerability discovery system framework. And the smart contract oriented vulnerability discovery technology to cover support the security vulnerability detection and the vulnerability prediction and the vulnerability search. So another issue is that the semantic driven systemic smart contract transaction exception diagnosis method. So throughout the smart contract-oriented anomaly analysis technology, so it can clarify the classification of smart contract exception, discover features of smart contract exception, and diagnosis the reason of smart contract exception. And the third issue is how to build the security analysis tool set to fill the gap in safety analysis tools and promote the practical application of the related tools. So here's some research content published in recent years. So it covers the smart contract vulnerability discovery technology, abnormal analysis technology, and security analysis toolsets. So let's go through it quickly to show that the smart contract vulnerability discovery technology, they have to cover the three vulnerability discovery scenarios and to the vulnerability detection, prediction, and search. So the solution comes from the S-FAST, S-GRAM, and S-clone in total. So it means it can take the vulnerability mode information and the smart contract as input. So the smart contract vulnerability discovery issue to generate throughout the tool to generate a vulnerability report. Um, well, so SFAS is using the fuzzing texting technology to detect the vulnerability. So here shows some key ideas throughout the smart contract uh, code converter and going through the fuzzy engine and the runtime trace, then to get the vulnerability report, which covers the vulnerable code location and exploit code. So vulnerability prediction technology is based on the language model, and you can see that the model training stage and the model prediction stage. Then they go through the S-gram and to generate the candidate sequence throughout the function sorter, and they can go through the whole process and to generate the more sophisticated vulnerability analyzer. Well, vulnerability search technology based on the similar code as clone to identify the similarity of the contract code to search for known vulnerability here. Well, for the smart contract abnormal analysis technology, so some research work covered the smart contract abnormal classification, gas exhausted, stack overflow, and illegal instruction, and insufficient transfer balance, and also other types. Yeah. So uh, here, one research work that is empirical research on the abnormal smart contract. So they can use historical transaction data to explore the basic characteristics, process, and the process of method of smart contract exceptions. Well, um, we can see that the smart contract abnormal analysis technology that can explicit state rollback and the gas exhaustion count for the majority and average and external transaction triggers multiple smart contract exceptions, and the denial of service attack generates a large number of gas exceptions. So here shows some data about that. Well, for the smart contract abnormal diagnosis technology based on the symbolic execution, the tool is called S-trace. So it can use a abnormal transaction track to analyze diagnosis and the course of abnormality. Here shows the process going through. Well, the third part is a smart contract security analysis tool set. So throughout the mentioned research achievement. So in our lab, we have established a smart contract security analysis tool set called S-Secure. So it consists of the S-Fast, S-Gram, S-Clone, and S-Trace as a core analysis model. So it can support the smart contract security analysis as a whole, right? And the integration of the multiple tool solutions can support the four types of security analysis scenarios. Right? Here's some interface about that. Well, so we can see that security contract security smart contract security analysis tool set. They can, in the practical way, to use combined tools for vulnerability detection and to do the analysis of abnormal smart contract after the deployment. Yeah. Well, here shows some results compared with some other experiments. Well, because time is quite limited, so let's give some summaries. So we can see that, yeah, in general, three security and vulnerability discovery technology for smart contract are proposed here, and they apply to the Ethereum smart contract and to do the vulnerability detection, vulnerability prediction, and the vulnerability search. And also, we can see that the classification and the occurrence mechanism of the smart contract abnormalities, conducting period research on the large scale real transaction data, and they have the characteristics and the main reasons of abnormality during the runtime, and propose that diagnosis technology for anomaly during the smart contract runtime. Okay, and also the SQL tool set was established, and they can put into the real use. There's also some research directions to cover the future uh, research, for example, how to improve the existing security vulnerability discovery program to support more type of vulnerability and combine the latest technology in related fields, such as BERT language model or convolutional neural network, then graphic neural network to apply for the vulnerability detection. And also further study on the characteristics of abnormal transaction tracks, such as the contract core relationship mode, and explore more runtime abnormal analysis problems. And also to consider how to improve the security analysis tool sets, optimizing the existing code and expand the test data sets and promote the practical development of the tools. Well, here is some reference publications listed and for the reference. Okay, thank you for your attention.